Okay. All right. So this is going to be a third, um, yeah, well, I don't know, a third attempt to record the third part of the small POC project. Before watching this, probably you should go and watch the first two parts. The first two parts about the Kubernetes management cluster POC with an NDAP. It explains everything, what you do and how you do it and such. And so this is specifically just to demonstrate how things can be done. Okay, so to recap real quick in a minute. So there is a cluster management pattern, which is actually a pattern used in service development, and it helps really to outsource management of the life cycle of components in an external, somewhere outside of a Kubernetes cluster, and kind of peer the Kubernetes cluster resources and the states and represent with their resources state somewhere outside of the cluster. Okay, and then I try to apply this to an NDAP platform. And in that platform, like I said, I've come up with a couple of custom resources. I've broken them into three parts: level 1, 2, level 0, 1, and 2. And these are resources that I will try to demonstrate how they provision and how they work, specifically through the CLI. And I'll show a little bit of the other parts maybe later, but generally it's just like that, basically very simple view at the CLI and what's going on through the Kube API, just through the Kube API, right? Okay, so the first order of business is what I'm going to do is I'm going to run my controller. So controllers, I'm going to run it separately in a separate window. You don't see this, but it's just starting right now. Right, so what we have meanwhile is that it's a normal Kubernetes cluster. It runs here. It's a K3D. It's running locally, but it can run anywhere you like, really. It's one node cluster, and there is nothing there really. It's just you could see there's just a Kubernetes service there. So when the controller starts, what you could notice probably already. Well, you don't see this, but some resource definitions. Right, so the first thing you probably would see here is that there are two things they're added recently. So these are two custom resources that immediately got provisioned when the controller starts. So that's the level 0 platform and level 1 component data extraction. Right, so these are two things that I will demonstrate how they're provisioning. So let me quickly talk what is a platform resource and what is a component resource. Platform resource is just a general representation of that everything necessary to deploy any component in an NDAP has been provisioned. So like it's basically the foundation of the NDAP platform. And so really, if we look at this content, the resource that I'm about to provision, it says very little really. It points to the project. So the whole work is done through one subscription. So I'm not defining this here. It only points to this one project to be 490. That's I'm going to be working with, right? So, well, let's begin with it. kubectl apply, and we're going to say it's another parameter we want to apply. What is it? Cluster. That's right. We want to apply a platform. Okay. So we're applying a platform. The resource has been created. So I've created my own group and NDAP, and let's see what's going on. Okay. So it's in the discovery state. All right. So let's see what's happening there. And then, of course, you should understand this is all staged. So I know what's going on. I'm just trying to demonstrate a case here. So we were going to look at the events. First of all, what I can do is that I can really get the status of this resource right away. But instead, I just want to jump into showing you what are the events are. So it's a platform example. So let me just fix this, okay, and we'll see what's going on. And it's saying something. There is an error, and I mean there is a way to really see this what's going on there. There's a more text, but I don't want to jump into this. I just know what the problem was right away. So it's a real case. I'm seeing like the problem's really this. So the project here, it doesn't exist really. The project's really called DP490, right? So and you see this thing's still hanging there. It's discovering, so it doesn't discover a project. So we could have reapplied the resource, but I didn't implement the update function. So what I'm going to do is instead I'm going to just delete it. So you see this thing disappeared, right? And I'm because I've fixed the problem. It's DP490, right? So it's now going to be. I'm just going to provision that again. I'm going to try to provision this one. All right, so now I'm applied this, and this should just work instantaneously. Okay, right, great. State ready, project's ready, right? So project. This is the project that I've decided defined in the cube, and yeah, you could go and sort of ctl get platform, and you could just do the whole thing, and you could see this is the output, and there's also whatever like messages and stuff, so many things you could find this all in the cube. This is not important. So now we have the platform API platform component that sits there and running. So what else we can do, right? So we have data extraction component, another YAML, which really does this thing. So it's a kind of component data extraction, right? And it has its own name, and it points to one thing. It points to the platform example 0. So you see, like, it doesn't really point at anything else. It doesn't have its own resources. All we say here, all we really want to say is that this component will be deployed to this platform, okay? And well, that's what we're gonna do. Apply data extraction. And apply it. So again, I go and I get all in that group, and what you see is that now we've got this resource and it's provisioning, and it's running. And so while it's running, I'm going to talk a little bit because this is going to take a while, maybe 5-6 minutes. So I'm going to talk a little bit about so what this controller really does, right? So underneath the controller API is fairly simple. How the way it talks to then end up is through the Azure pipelines. The Azure pipelines is a very simple interface, but they don't have a state. So like one thing I have to really implement is having a state. And it's the way it works is that whenever I receive a component that that has been created, maybe let's look at its undergats component D. See, so there are a lot of things. So first of all, there's a status last run ID provision. So this is actually this is a pipeline ID. So sorry, it's not a pipeline ID. It's a run ID of the pipeline, and you see this is the state of the provision pipeline, and it's in progress. This means that the pipeline itself was still running, and we can't really say that the component's ready. So the overall state is set to provisioning. There is a pipeline state here, so we don't have to go and kind of read it every time. We can just fetch it from the status, but normally we don't want to see this. So this is a bit of a simplified view of components. So what controller does when the component is created, the controller will go around the pipeline. Well, first of all, it'll find the pipeline. We have one particular pipeline to look at, so there is nothing fancy there. It's just one name hard-coded, and it will actually go get a pipeline from this project in Azure in the NNDAP organization, or whatever the term is for the big overarching kind of like abstraction in Azure. And it would just look at the state of this pipeline. So remember, we remember the state the actual state of the run of the pipeline in here in the status. So whenever the controller has been stopped for some reason, one or another, it doesn't have to kind of keep this in memory, because when the controller restarts, of course, it doesn't know anything about all the resources or any resource of this matter. So what happens is whenever a retry operation comes into controller, it will look at its own status as well and see, oh, okay, so this the operation is provisioning, the state is provisioning, and the last run ID provision is this. So it kind of deduces its own state at this point, and it'll go to Azure DevOps and it'll check this run status and it'll update the state provision operation, right? Not operation status. And it'll keep doing this until the pipeline is completed in one way or another. So again, I don't have really a complex model handling all the possible states of the pipeline. So if the pipeline fails, or I don't know, it's been canceled, the whole thing would just break, of course. And I'm not looking really at the logs or whatever else. However else I can really deduce the result, the outcome of the pipeline. It can be that the pipeline failed somewhere in the middle. Actually, it does sometimes, but I don't see this. I don't check for this. But it's not important. I mean, we're just kind of looking at the general use case. So we'll look at this. This is still running, and like I said, this is going to take a while. So again, I didn't implement update operation for the resources, so you can only create and delete them. But what I did implement, of course, is that I'll try to demonstrate it. But in principle, what I did implement is the following. So the component DE, when it deploys, like I said, there's this specification. Where's this part? The spec, the platform reference, right? So the controller of this component will only proceed to the deployment state, or it will call the pipeline only when it can look at the platform name, discover the platform name, discover the platform with this name. This is colloquially referred as a selector. Well, it isn't really a selector, but it functions as a selector. So it's actually, it will find a platform matching this pattern, right? So it's a name, and selectors work a little differently, and they're standard. So I didn't use the standard model. I just kind of wanted to demonstrate there's a dependency. So if you remember when we deployed platform, it wasn't ready, so it was in discovering state. The component would not even deploy in the first place. It would just stay there in a pending state. So this is, and once it's ready, it'll actually proceed to deploying. It's still running. Okay, so let's see how far we are with that thing. 419, yes. Oh, it's still running. Okay. All right, but we're almost in the end. That's good. All right, yeah, we're about to complete the run. So what else should I say? We could, well, the important part about components or controllers. Let me see the code. So everything is going to be shared in the code. Like I'll give the references in the end. What else? Yeah. That's pretty much all, really, because let's wait. Let's just sit and wait until it all completes. All right.
Okay, so the pipeline is just completed. Let's see if there is any change. And it's still provisioning. Okay, let's wait until its next event. So it'll be probably about a minute or so, because I don't know exactly where we are right now in the reconciliation loop, but it should just be about a minute or something. One important thing to actually say about the Kubernetes resources, how they're provisioned, right? So whenever I create a resource and it somehow is in a state, discovering, for example, you shouldn't be really thinking that Kubernetes thinks that this isn't ready. This is not a ready resource, right? Even though Kubernetes has healthiness and keep alive kind of mechanisms to ensure that the resource is ready, but this is all very separate from the discussion. This can be also implemented and used. But from the perspective when a resource is just created, Kubernetes already thinks that the resource exists and it has been created. Now it's a task of the controller to update the status of the resource, even though it's been already created. So there is an actual representation of the resource. So it's already a job of the controller to kind of change the state and make the state whatever, or any other parameter or property of this resource to be something else, right? So from the perspective of the Kubernetes, resource is created, and now it's just only tracking the updates to this resource, whatever the updates are. It could be, its status change, it could be a spec change, it could be whatever else. But it's the controller that now updating this resource. And it's important because what you'll see when the deletion happens. Okay, so you see the component is now online, and it's up and running essentially. So we could kind of go and read the status of this, and you see what happened is that, again, the same run ID, this state is online. This is what we said in the controller, and then the state provision, it's the status of the pipeline that run also completed. So that kind of directly translates in the status online. Again, we could do more checks and we could do regular checks, but that's how it works right now. So this is a bit more like a high-level view of the status of the component. So now what we can do is that we can actually go and delete component, right, like this. And that's a little bit different. So now notice we call the delete, and Kubernetes, well, it's not a Kubernetes, it's the kubectl. It sits there and it waits until the operation is actually successful, right? So if actually I go and then I check, okay, let me reshare. If I go and check the status of the resources, check the status, get and out, you'll see that the component is in the state deleting, but it's still there. So again, Kubernetes didn't delete the component, the resource yet. And the reason why this happens is because of this. So there is a functionality in Kubernetes called finalizer, right? So Kubernetes will never delete a resource until the finalizers are empty. And so what's happening right now is that the controller framework will keep this record here until the reconciler loop exits with a successful result. So when the reconciler loop exits with a successful result, it will clean up the finalizer and the resource will be successfully deleted. But until that time, we sit and wait, and Kubernetes sits and it doesn't delete. It prohibits this component to be, or this resource to be deleted, until our controller tells it to clean up the finalizer. And then, of course, magic happens. The controller, the resource has been deleted. And again, the change of the state here is, it doesn't relate to any change of the state inside of the Kubernetes. It doesn't represent any change state in the Kubernetes. Kubernetes has only changed its state when we attempted to delete it. The indication of that is the deletion timestamp. So whenever you have a deletion timestamp on the resource, that's an indication that the controller is working on it, and it's been asked to delete something. There is a grace period of 0 means never, which is bad, but it doesn't matter really. The important thing is that it's going to sit and wait until we. Oh, by the way, and notice, by the way, now there is a last run ID remove. So this is the pipeline that's removing. It's actually sequentially the next number. So and it's in progress. So it's going to be in progress there until it completes. So it's deleted, and we of course we set up the state deleting ourselves. So again, from the Kubernetes point of view, nothing changes really. The thing still sits and waits until we clean up the finalizer, right? So let me see how we're doing on the pipeline front. It's running. Should be a little bit quicker, but Terraform's never fast. Okay, and yeah, so this is the deletion part. So just mind that there is this blocking delete, and this is the mechanism for for deleting things. And by the way, you could implement the same model for creating dependencies. For example, if I wanted to delete the platform, I would have added here another finalizer, which would be maybe like an end-up platform finalizer or whatever. So when I delete this resource, it will never get deleted until a component controller allows it to be deleted. And you do it so that when you delete this platform, the component controller will first clean up its resources. It's all resources. It has a way to actually go and check all the resources that it has, and then delete them. And once they're all deleted, it would remove its own finalizer, and only then this resource can actually be deleted. It like in the Kubernetes way. I mean, Kubernetes will forget about this resource, and when it forgets about it, the controller of a platform will let it go, and it wouldn't have to track the state and such. So I mean, the whole controller model is fairly complicated. I must say that this isn't an easy ride. You shouldn't have any delusions about, oh yeah, we'll just write a controller, which is very simple. No, controllers are hard to write. They're hard to write reliably, so they work reliably. So they are stateless, and many things. But at the same time, I mean, it definitely adds more effort to everything. But the advantage, of course, is that you're just getting this very simple, overview of everything to manage everything through one API. And to me, this is worth more than just the effort to write a controller, And again, the controllers don't have to be absolutely reliable. They can crash. It does. I mean, it's nothing bad about. I mean, they shouldn't be crashing, of course. But if they crash, and if they're written at least in a decent way, so they're stateless, they can be restarted, and the whole thing can be picked up and just carried on. Even the controller itself can be stopped for some reason. Okay. So. Let's look at some other properties here. So you see there is an owner reference. So there is a owner reference platform example. That's what I set in a controller, and that works another way around. So if I delete the platform, oh yeah, it works in exactly the same way. So actually, without even finalizers, you could tell the Kubernetes that when you delete this resource, you have to delete its own dependent resources. So this is component data extraction, and it depends on the platform. So in this particular case, it will implement so-called cascade delete, where if the parent has been deleted, it'll actually delete all its children, without kind of implementing additional functionality in a controller. So that's a very convenient thing to have actually for some resources. What else is interesting here? You can see the generations. This is just you can tell how many times this thing been updated. It's been updated 6 times. What else? You could sort of see the unique ID. I mean, not that it's important. The resource version is something that gets incremented every time. It's something similar to generations, but as far as I recall, the resource version does not get updated every time, because you might update the resource without any changes. And that would probably trigger the generation change, but it wouldn't trigger the resource version change. So there is some funky logic that can be implemented when you're comparing, when you try remembering the last resource version to the current resource version, or last generation to the new generation, last known generation when last event arrived. So because your controller can actually keep that in runtime in memory, and maybe do something about it. You could see like maybe some updates or something. But at the same time, controller API will provide you the difference, and the difference between the old state and the new state if something changed, of course. So it's not important for you create events or delete events, because delete event is the old state is this, the new state is nothing, and create state is the same. But whenever you have the repeating events like retries or updates, it's sometimes convenient to know what has changed really especially with updates. You don't have to delete a resource and create it once again in order to maybe handle the separation. So the controller will actually give you that information right away. I should say not the controller framework, of course. Maybe while this thing is running, just to tell you, I don't know if Python's the best way to write this controller, because I know for sure that the pipeline actually maybe failed. Interesting. Well, it doesn't matter. The pipeline failed, but because we're not looking at it, and it's Terraform, so even if it failed in the end, deleting maybe one resource or some more resources, it's not important. Most of them are gone, and we can kind of assume maybe almost safely that the resource has been deleted. Well, it's still been deleted, of course, but once we have another event, that resource should be cleaned up, and then we could try something else. I'll show you how dependencies work. So I'll try to do two things. I'll try to demonstrate what happens if I provision the component without a platform. Then I'll try to demonstrate what happens when I provision a component with the platform and the platform is not working. I mean, these are all the use cases, hypothetical use cases, but and then I'll show you how that can be synced up with repositories. Okay, see, the component is gone, right? So that's good. That's very good. So that's just disappeared. Okay, so this is first use case. You created, you deleted things. Okay. Now let's delete our platform. All right, we deleted the platform. Nothing happened. Well, I mean, it's been deleted. Controller handled that easily. And then, so we're gonna do is that we're gonna again provision our platform component. So we apply that, and well, guess what happens? It's in a pending state, because there is no project, there is no platform available. So what we're gonna do is that we're gonna do the same exercise, and in platform we'll change it to DB, and we'll do that again. And again, everything kind of works, but it's pending, right? Oh, it's ready. Oh, look at that. Did they? Man, okay, there must be a bug somewhere. But interestingly enough, this thing is still pending, right? That's because this platform, this project's really not okay. Don't do live demos. But this project, doesn't exist. So what we're gonna do? Brilliant. What we're gonna do is that we're actually gonna change this to DP for 90. Okay, and we will provision this. And actually, I'm not even sure what's going to happen, to be honest, because, oh, you see, because we deleted the platform. That's interesting. I didn't test this, but I've deleted the platform, and it actually deleted the dependent component with it. And I didn't even have to think about it. Okay, so that's how it worked, right? So, and then we will just provision the component. And by the way, that's why you want to implement update operation, not a create and delete operation, because update would be more appropriate here, actually. And of course, the same thing happens again. So we kind of run it, and it runs, and you know the usual thing. All right, so that's the second part of this demo. So now I'm gonna do something bad, which is I'm gonna really just try to kill everything, kind of like almost live. And what I'm doing here is I want to demonstrate how to sync this thing with a repository, right? So again, this thing is running. What we're gonna do is we're gonna delete platform. This again is gonna hang, and what we're gonna do then, we will remove all the finalizers from our platform, right? And we will delete all the finalizers from our component. And that will let Kubernetes, and we'll let the Kubernetes do its job. You see, it deleted everything because the finalizers are empty. So our controller has never been asked really to handle the delete operation, because once we asked Kubernetes to delete something, it just disappears, right? So there's nothing really to handle in the controller. Even though controller actually receives an event, it's a little bit meaningless because the resource doesn't exist anymore. So the only thing the controller can do really is, if there is no finalizer, to kind of try clean things up in like in one operation. And if it fails, then it fails. It's just sad, but that's it. Okay, so what I have here is how do you sync this with a repository? This is something that I know can be done with Argo CD. I'm doing it with Flux. So Flux get customizations. I have two customizations. One is the Flux system, which is its own thing, and also I have an end-up system customization. So what is this? This is just that. It's a customization file. I mean, it's all sitting in Git, but I'm not going to show Git. I'm just going to show what's going on here in files. This is already a checked out file. We could Git remote. What is it? A or something? How do you print those? Well, anyway, so this is a Git repository, and this is exactly so when the Flux will not really, of course, synchronize it with my local folder. It'll go to the repo, and it'll actually pull the stuff out of the repo. But I wanted just to show you what's in the repo here locally, because this is an exact copy. So these are actually two files that have been deploying here. So the customization only mentions these two files, platform and data extraction, right? And well, I mean, all I have to do is just to tell Flux. I already configured Flux to look at this customizations. This repositories. So all I have to do is just resume synchronization with that thing, and keep again, just to demonstrate there is nothing happening here right now in the cluster, right? And then I'm gonna do this, apply, and it just runs. So if I go and check this, you can see that both resources just been created. They don't even have a status. So they they don't have a status because my controller is not running. So I'll run a controller, and the controller will start handling everything. So it's still pending. See, you see the platform change to state ready. After a while, the component will start provisioning, because now it's kind of sitting and waiting. Even though the component controller could see, could watch this resource, meaning that whenever it's been updated, it actually get some event right away. I don't do this. I just do this like once in a minute, I think, or something. I don't remember exactly what's the state of the code right now, but I mean, it doesn't matter really. Yeah, that's just implementational details, how it works. So yeah, that's pretty much the same repository where you could have, you could have custom resources and end up custom resources too, but this is more abstract way. I mean, the customer, we're not really bound to using Azure DevOps or Flux or Argo CD or any other tool. It's all really now in the hands of CI/CD guys how to do this, because it's just a repository. So you see it just started. Okay, so and Flux really just goes and you could actually go check what Flux really thinks, which customizations. It's not suspended. It tells you the Git version, blah blah blah, and in Flux you can actually configure even keep alive, and it'll tell you if this thing's been alive or something. So, but that's again tooling. The important message here is that you can delegate it to tools and implement maybe in your controller additional functionalities or in your resources additional functionalities. But that is, that's a different set of APIs. And the best part about it is that you can actually approach that differently, separately, optionally, whatever way you like it. Okay, so just to maybe maybe to demonstrate that everything's kind of running and such, let me show it that the pipelines, actually provisioning pipelines, are actually running. So you could see that this is the project, this is the pipeline that I've been running, and it's been running here. You see, these are the pipelines that I actually kind of didn't cancel. So this is when the controller didn't work properly, and the leftovers of the pipeline are actually still here. So we don't want. I mean, it's just unfortunately the POC's nature of things, so they're broken a little bit. And this is the last pipeline, the provision pipeline, and it just runs. So that's it. This is the POC. That's how it works. I'm going to send links to the repos where things are. And well, I want to thank everyone who actually managed to get to the end of this demo. I hope you didn't have any questions, because we are separated in time. I'm now, you are them. And if you have questions, you know where to find me. All right, cool. Later. Bye-bye.